Welcome to Brain Vision.
Hello and welcome to this video solution of Numerid. So here it's given that a worker wants to turn over a uniform 1250 Newton rectangular crate by pulling it at an angle of 53 degrees on one of its vertical side. The floor is rough enough to prevent the crate from slipping. Right. Now what pull is needed to just start the crate to tip? Now what you can do is, let's say I take this force to be F, right? And you need to balance the moment about the point, let's say O, right? Here you have got two force. One is this force F acting at an angle of 53 degrees with the vertical, and there will be the weight of the crate, right? That is 1250 Newton acting right from the center, right? So if you take the moment about O, a summation of moment about O and equate it to zero, you will be having this is F sine 53, that is the component of this force, this one, right? This F sine 53 degrees, right, times this distance of 1.5, that should balance the weight, right? The moment due to weight, which is 1250 times this 2.2 by 2, right? This one, distance from here to here. And clearly from here you will be having F to be equal to 1.15 times of 10 to the power of 3 Newton, right? Here's a force F. This is required to tip the crate. Now how hard does the flow push upward on the crate, right? Now this is pretty simple. So here you will be having the component of this force I take on the vertical component, which is F cos of 53 degrees. The weight is acting downwards, there will be the normal reaction N, right? So based on this you will be having the normal reaction N to be equal to uh, W plus F cos of 53 degrees, right? And this is 1250 plus 1.15 times of 10 to the power of 3 cos 53 degrees, right? And this will come out to be around 1.94 times 10 cube, right, Newton. So this is a normal reaction now. Now C, you have to find the frictional force on the crate C. So the frictional force Fr will be equal to F sine 53 degrees, because this is the horizontal force, right? And this force has to balance the friction on the opposite side. And if you evaluate this, then it will be around 918 Newton. Right? You need to plug in F to be equal to 1.15 times 10 to the power of 3. And finally, D is the coefficient of static friction, right, mu, which is equal to the frictional force over the normal reaction, right? So it's 918 over, this is 1.94 times 10 cube, right? And this is 0.473. I hope this is clear to you, and have a very good rest of the day. Thank you.